Yeah, hello everyone. Welcome back once again. So today we will be talking about chapter 9, that is comparison of two samples. So how do we do comparison of two samples? We break this into four different sections. One, we are going to compare these two samples based on the mean, but it will be with large independent samples. And in section 2, we are going to compare based on the mean as well, but this will be with small independent samples. And in section 3, we also do the comparison for mean, but this will be for dependent samples. And in section 4, we are going to talk that of the for the proportion. Okay, so we have these. All right. So let's consider an example to get a fair idea of what we mean by comparison of two samples. But before we get there, let's let's see an overview or an example of what we mean by two different samples. So here we have a university administrator asserted that the upperclassmen, all right, spend more time studying than underclassmen. So you could see that there is some kind of comparison, and this comparison is between what the upperclassmen, as we see, and that of what the underclass what men. All right, so in here we group them into group 1 and group 2, or we can classify them as population 1 and that of what population 2. So we have accepted that the upper class term spend more time studying than that of what. So how do we test something like this? So we need to actually verify the claim of the university what administrator. All right, so that is what we mean by comparison of two samples. So we are comparing two different what samples. But before you do that, if you want to compare, sometimes within that population of the upperclassmen, we don't know all of them, so we might actually take some kind of samples. So in the upperclassmen, we may take a sample and label it as what N1, as we see here. And in the underclassmen, we might take another sample and label it as what N2. So in all of these, if you take a sample, you can calculate their sample mean and their sample standard deviation, as you can see. Are we okay? All right. So these are the two population for us to consider as an overview for the comparison of two samples. What is the goal? Our goal is to estimate the difference between the population what means. All right. How do we estimate the difference between the population mean? So we have that of the point estimate, and we have that of what the interval what estimate. I believe that we all know that if mu1, which is the population parameter for population 1, then the point estimate will be s bar 1, as we see here. Okay, and mu2, the point estimate will be for what? S bar 2. But if I take the difference between mu1 and mu2, then what will be the point estimates for them? Then that will also be what? S bar 1 minus what? S bar 2. Then that is the point estimate for uh, the difference between these population what means. In as well, we also want to get an interval estimate. So we want to find an interval for which we believe that the difference between these two samples, these population means will actually fall within what? This interval. So we also have that of what? The interval estimate. Just as we've done already in the one sample case, we did maybe S bar plus an E. Okay. So in the one sample case, we did S bar plus an E, and E is the margin of error. So if you've forgotten, just revisit your book and you are going to get it. In this as well, we want to actually add a margin of error to it. So it's just similar to what we've actually learned early on. Okay, so we are going to get to know what this E is. So we have that, if you have the point estimates, if you have the point estimate here, then you add some margin of error, which is what your E, and subtract some margin of error, which is the same as E. So what is this E? So this is the E that we are talking about, that you focus on. Okay, but note that in 9.1, we are dealing with large samples. What do you mean by large samples? We need the N1 and N2 to be greater than what? Greater or equal to 30. That is what we mean by large samples. So if you want to construct an interval estimate for the difference between the population means this, then this will be how you do it. Are we okay? All right, so we have the formula as well here. So this is the formula, as you can see. This is the formula. Okay, and there's a shortcut way using the calculator to do the two samples. So here we are dealing with two samples. So you have two sample z interval. So when it is last sample, we use the z. So if you go to stats, you click on test, and you are going to see that of what the z interval. So let me demonstrate using the calculator here. So if you go to your stats, you go to test, then you scroll down to sample z, not z test, z interval. Okay, so that is it. That is the 9. You click on it, then you fill in the details that you want. So you go to stats. So if you have stats, you put in the stat. But if a raw data is given to you, you click on the data and you are good to go. But before you use the data, make sure to use your list 1 and list 2, and you are good to go. So how do you use the list 1 and list 2 given the raw data? So before you come to this, note that when you click on start, you can go to edit. Okay, so you have L1, L2, input your raw data there. If you're done, click on start again and come to the test. Now you can scroll down to that of the two population, two sample Z interval. Okay, now you're good. So now you're using the data, you're not using the stats. But if you are giving the stats, just go with the stats. You don't need to input any data. So input the information given with you in the question, and that creates an interval for you. But what the calculator does is that it creates the interval for you. So it might create an interval like if you have the final answer to be this, there might be a value here and there might be a value here. This is what the calculator is going to give you. But in certain cases, I might not need this actual interval. I might need maybe my value, maybe s bar 1 minus s bar 2 plus or minus the e. Okay, I might need the value here, and I might need this value. That is all that I need. In view of that, then you have to use this formula to do it. So you focus on this and calculate that. Okay, so samples must be independent and both samples must be large, as you can see here. So what do we mean by independent? Samples are independent if each data value from the first sample is no relation nor connection to the second sample. So they are independent by definition of independence. So we have some example here for us to demonstrate what we are talking about. Okay, so like we said that the university administrator took random samples of upper and what and a class. So we have accepted something for the administrator to test it. He or she took a sample to test his claim. Okay, but first of all, he wanted to create a confidence interval for which he believed that the difference between those two population means might lie within that interval. So the administrator took a sample size for the first group. He took 35. For the second group, he took what? Another 35. So 35 here coming. So you could see 35 here, 35 here. The mean for this 35 sample is what? For the first one is this, and that's for the second sample is 12.3. And we have their sample standard deviation S1, S2. Are you okay? All right. So these we've been given the statistics. So if you are using the calculator, you go to the stats. You've not been given the raw data. Okay, but in certain situations, you might be given the raw data to use. So we want to construct an interval for what? mu1 minus mu2. So this is the interval estimate for mu1 and mu2, and we are going to use the formula here to do it. Since we are using large sample, then you're going to use this to do it. All right. So what we have the s bar 1, s bar 2. So you subtract them based, use the formula, don't change anything. So s bar 1 minus s bar 2. Always know that the first row or the first column given to you will be your first group, and the second row or the second column will be what? Your second group. Okay, so label them as such and you'll be fine to go. So what do we need? We need this value, and we did that. We did just that. So we had it to be 3.3. And we need a value here, that is ZF over 2. So how do we calculate the ZF over 2? That is the inverse norm of alpha over 2. So based on the question, you have to compute a 95 confidence interval. And the alpha is what? 5%. You divide your alpha by 2. you can calculate that. So we use our calculator to get the z alpha over 2, which is approximately in two decimal places is 1.96. If you have this in the mind, you are good to go. You don't need to. But if you don't have it in the mind, you can calculate it using your calculator to get your z alpha over 2. Then you bring your square. So you are just apply the formula and you're good to go. So we have s1. Here has been given s1, but here is s1 square. So take the value of s1 and square it, divide by n. Take the value of s2 square it, and divide by what? 2, and you're good to go. All right. So that is what we were doing, and we had a value. So it might be that I need an answer like this. I don't need the whole interval. I need an answer like this. Or the calculator will give you this answer. Are you okay? All right. So you have to note how you can do that. So this is a confidence interval. Very simple. It's just the same thing as. So you can also use your two sample z interval, and it's going to give you the final answer like this. It wouldn't give you something like this. It wouldn't give you that. All right. So you can also explain the confidence interval. Normally, based on the confidence level given, then we are 95% confidence that the mean difference of the two populations will lie between the interval created. Okay, so you don't need to write this. So maybe we are normally you go back to the question. So what is the question saying? Say compute a 95% confidence interval. Are you okay? Compute a 95% confidence. So then therefore we are so we are 95% confident that the mean difference of the two population you're 95% confident that the mean difference of the two population lie within the interval. So this is the interval. So the final answer that you get, you bring your interval. It's just simple as that. Then you're good to go. Okay. This explanation is respect to what the question is saying. And after creating an interval, sometimes you want to actually also test it. So if whenever you hear tests at 5% significance level, it implies that we go through those five major steps. So we have 5 steps that you go through in testing. First of all is to actually list your. So whenever you hear test this, but construct an interval is just what we just saw. But test. So if the question says test, it means that one, write your hypothesis. H naught, maybe mu1 minus mu2 is equal to some number that we don't know. And 2. And HA, so this is the alternate. Then mu1 minus mu2 is greater than d naught, or mu1 minus mu2 is less than d. Sorry. It's less than some d naught, or mu1 minus mu2 is not equal to d naught. All right. So this is what the alternate hypothesis says. All right. So in your bet, always this should be it. For null hypothesis, it should be written like this. For alternate, chooses these 3 directions. Are we okay? Based on how the question is formulated. So always the question will be formulated either more than, less than. It will be based on the alternate hypothesis. So if it is more than, it's greater than. If it is less than, if it is below, it's less than. So those, we have some verbal statements that will help you write the alternate hypothesis. Okay. And if you are done with the first one, then you find a value. That is the z test statistics. And we have the formula there. So that is the value here. Okay. You find that value. And your third is that you find your rejection region. you know how to do the rejection region. It's the same thing. Rejection region or your p-value. You also know how to calculate the p-value. It's the same thing, nothing is changing, just that the z-value, we want to know how to calculate it based on two samples. Then the 4, that's what I'm saying, that is just the same. And 4, you make a decision. You make a decision. So how do you make the decision? Either your z compared, z compared to your rejection region, or you have your p-value compared to the alpha. Compared to alpha, all right? Then that will help you make your decision. And we've done this comparison. So if you revisit it, it's the same thing that applies. So that is what we are doing. So we did that and we input the details that we have in the formula that we have here, and we are good to go. But what did this actually say? It said that, okay, I think okay, let me see. Okay, this is actually a different question. All right. So here we have to test. Okay. So we have a claim that the resting heart rate of men age, okay, 18 to 25 who exercise. So we have those that exercise. That will be our first group regularly. It's more than 5 beats per minute, less than that of what? Men who do not. So we have men who exercise in the age and this age category, and men who do not exercise in this what age category. So we have two categories, okay? But what we are saying that based on the statement, we are saying that the first group is more than 5 beats per minute, less than. So this implies that the second group is greater than the first group plus what? 5. Are you okay? That's how you actually, so that's how we state it. So the second group, the mean of the second group is greater than that of the first group plus what? 5. That is it. So this is where the claim lies. So if you have something like this, you have to rewrite it back to mu1 minus mu2, just as the alternate is saying. So always this sticks. The H naught does not change. Note that it's always mu1 minus mu2 equal to some number we don't know. We are here to define, we are here to find out that number based on HA. So you find D naught based on what? The HA. Okay, so H naught stays the same, but is D naught 0 or different than 0? Are you okay? So based on the statement in the question, that will help you determine how you are to actually. So first group you use mu1 for it, second group you use mu0 for it, mu2 for it. Okay, so if you're able to identify these two groups, your first group will be your mu1 and your second group will be what? Your mu2. So here you realize that it's less than that of, okay, so mu2 is greater than mu1 plus what? 5. So that is what you did, and we have to rewrite this back to this. So after rewriting it, then we were able to find our D naught. So here our D naught is what? Minus 5. Okay. If you have this, then you're good to go. So you write your hypothesis. So always try to define something like this. Try to find this based on the statement. Then you rewrite back your hypothesis. Finding the D naught is very important. Okay. So that is what you were doing. Okay. So that is where the claim is, and we wrote our hypothesis by finding the D naught from the question, and we test the statistics. So the test statistics will be the formula given in the question, and given this data, we just fix it in. So we have the data here, and we fix that in. Okay, or you can use our two sample z test. So in here we talked about two sample z interval, that's for interval, but for test we can use the z sample z test. So it gives us the test statistic. So that one, oh, all right, so you hit on the stats, you go to test, then you choose two sample z test. Are you okay? We've been given the statistics, so we put in the data. But if you are not giving statistics and raw data, then you have to go to the data. Before you go to the data, make sure you've input your data here at edits, the list one, list two. If you input the data there, then you go back to your test and choose what to sample z-test. And now you hit on the data. Okay, then you work with that. That is it. Okay, so that is that. The status is all. Okay. If we are done with that, we get our z value. If we get our z value, then we determine our rejection region based on the steps I have written. So I have written the steps here. So third, we determine our rejection region, and we know how to determine rejection region. It's not different from what we've learned early on. And the p-value too, we've determined it. You know how to get it. So I'm not going to go through that. If you've forgotten, you can email me and I'll be glad to take you through. Then we make a decision and we draw our conclusion. Then that's all. The same thing applies to this example. We go through the same. So always, so H15 will be our first sample, H30 will be our second. So based on the statement, then we determine our D naughts under the HA. Okay, so the first sample will use your mu1, second sample will use your mu2. So we have those that depart in H15 using the train, and those that depart in what H30. Yeah. Okay, so based on the statement of the question, we're able to write down our hypothesis, and we are good to go. Oh, sorry. So we do same. Okay, so this question actually merged everything together. So first of all, we have to do our confidence interval like we did early on. And we do that of what? The test. So I said if you hear test, you go through those 5 steps. Confidence interval is very simple. You just do that and you're good to go. Okay. But the what is very important here is that if you are using the calculator for z-test, 2 sample z-test, and your d naught is not 0, then it cannot work. Okay. If D naught is 0, the Z test works perfectly. So in our case, we have the D naught to be what? -5. So the calculator wouldn't give you the right answer. So you have to go through the steps. You have to use this formula to get your Z test. Okay. But if the D naught is 0, assume that we were having it to be mu1 minus mu2 is less than 0, then we are good to go. So assume the statement was like men aged 18 who exercise regularly is less than that of men who do not. So men who, so we have mu1. Based on that statement, we have mu1. Oh, sorry. You're going to have mu1 is less than mu2. Simple. So how do we write this back to this? Then we subtract minus mu2 here, minus mu2 there. So this is left with 0. So if you write it again to mu1 minus what? Mu2 is less than 0. We are good to go. Okay. So if this is 0, D naught is 0, the calculator to sample Z test works perfectly. But if it is not D0, if D0 is not 0, then we can't use that. You have to go through the steps given. All right. So note it's very important. We do same for this question based on the statement. So to conclude that more passengers ride the 8:30 train. So this one we've hit the 8:30 train. So 8:30 train, more passengers ride the 8. So mu2 will be greater than that of what? Mu1. Okay. So mu2, because based on this, the 8:30 train, the 8:30 train is the second row, and the first is the second sample, and 8:15 train is the, okay, so that would be our mu2, and 8:15 is my mu1. Okay, I'm explaining this in details because it's very important to understand it, and that's why I've taken time to explain this part. But I believe in the subsequent ones, I wouldn't take much time to explain it much. So conclude that more passengers ride the 8. So what are we talking? We are talking about 830 train. So if you want to write that of the hypothesis, then the 830 will be the mu2 is greater than what? Mu1. That is not what we want. We want to write, so we have mu2 is greater than mu1. But the H naught says you should write it as mu1 minus mu2 is either less than D naught, greater than D naught, or not equal to D naught. So how do you write this, Nick? Then I have to subtract minus mu2 here, minus mu2 there. So here will be 0 is greater than mu1 minus what? Mu2. How do I rewrite this so that this becomes the first one? So this will be mu1 minus mu2. So this, the bottom. Okay, so this and this are the same, but we prefer to write this. So now my D naught is 0. If the D naught is 0, the calculator works perfectly. You don't need to do anything. You can use your calculator to get your final answer. So that is what we did. That is what we did. All right, so this is actually for the comparison of two samples using the mean, but we are using large independent sample size. All right. Thank you, and I'll talk that off 9.2 very soon.